Bismillah ar-Rahman ar-Rahim. Today, this is our second session in revising for your placement test. And today's objectives will be solving problems of velocity, acceleration, and free fall motion. The second objective will be solving problems of two-dimensional motion. And in the two-dimensional motion, we will be discussing the two types of the two-dimensional motion, which are the projectile motion launched at an angle. First of all, the launched horizontally, and the other one is launched at an angle of theta. So those are the first two objectives, but before starting our objectives, so we need to revise some important rules in mechanics. We will start with displacement. And displacement basically is a vector quantity that identifies the change of the location of the object, and the change of the location would be delta x or delta y. It depends on the dimension that you are moving on. You might move on the x-axis, so it would be your final position minus your initial position. Delta y, it would be also your final position minus your initial position on the y-axis. So this is the displacement, and it is measured in meters or kilometers. And it's a vector quantity because it might be positive or negative. The second formula that we need to discuss is the average velocity, and the average velocity is V average, and it is defined as the rate by which displacement changes by time. So this means that it is equal to displacement over time, or delta x over delta t. An average value in physics, just like the math, it is the sum of the values divided by their numbers. So you have two velocities, basically Vi and Vf, and their average would be calculated by dividing both velocities by 2. So basically you can calculate your average velocity using two formulas, delta x over delta t, or Vi plus Vf over 2, which is the normal way of finding the average values in math. And it is measured in kilometers per second, kilometers per hour, or meters per second, because it is displacement over time. So as we discussed earlier in the dimensional analysis, this is a length and this is time, so it is meters per second. The third formula that we need to remember is the acceleration, and the acceleration basically is a, which is equal to the change in velocity over time. So this means it is the rate by which velocity changes, delta v over delta t, or in other words we can say that it is Vf minus Vi over delta t. So it is the rate by which velocity changes, and this is the acceleration, and it is measured in meters per second square. So it is measured in meters per second square, or kilometers per hour square, because it is velocity over time, so it is meters per second. This is the change in velocity over time, which is second, so it is meters per second or meters per second square. This is how we derived the unit. So we discussed the displacement, we discussed the average velocity. So let's write it here. This is the average velocity, and this is the acceleration. And we identified the units of each. This is meters or kilometers, this is kilometers per hour or meters per second, and this is meters per second square and or kilometers per hour square. So these are the important formulas that you need for the one-dimensional motion. There are some other formulas that you need if the case is a uniformal acceleration. So in such case, we need to highlight it. So let's here write, because this is basically a very specific case that is being highlighted in the placement tests. So in the case of uniformal acceleration, we have to write this in here. In case of uniformal or constant acceleration, or if the question said it is a free fall motion, which means an object can be dropped or thrown upward. So all of these are keywords that tells you that you have to use the 4 kinematic equations. So if you found the problem saying that an object is moving in a uniformal acceleration or constant acceleration, or an object is dropped or thrown upward or a free fall motion, you need to use 4 kinematic equations. And the 4 kinematic equations basically are easy because 2 of them, we have just mentioned them now, and the first 2 are those ones. You just change the shape of the formula, you will get the first 2. So the first kinematic equation is delta x is equal to half vi plus vf times delta t. And this looks exactly like this one. The only thing is that we changed the shape of the formula. Delta x over delta t is equal to vi plus vf over 2. If you cross multiply, or you just put the delta t in the other side, you will find out that delta x is equal to vi plus vf times delta t and a half here in front of the formula. So it is just a rearrangement of the first formula of the v average. So this is the first rule of the first kinematic equations. The second one is vf is equal to vi plus a delta t. And also this equation had been mentioned here. This is the same equation as this, but also we rearranged it. So Vf minus Vi is equal to A times delta T by the cross multiplication. And then you solve for Vf, you will find that this equation is also this equation. So those 2 equations are given before, so you don't need to memorize them because you already know them. The third kinematic equation is delta x is equal to, you just can copy this equation as it is, Vi, leave a space, plus A delta t. It looks like the upper one. We just add delta t here. And if we added delta t here, this one would be delta t squared. And you just put a half in here. So this is the third kinematic equation. Delta x is equal to Vi delta t plus half A delta t squared. The fourth kinematic equation is Vf squared is equal to Vi squared plus As you can see here, the A delta t, we have never mentioned A delta x. So put A delta x and just put here 2. So this is the fourth kinematic equation. So the question now is, when shall I use the first, the second, the third, or the fourth equation? Is there a rule, or I have to figure out from the givens and waste my time? Before we do anything, you just do this simple trick. In the first equation, the second equation, the third, and the fourth, you will find something missing. You will find 4 given values, but a missing value is not there. So delta x is the displacement, vi is initial velocity, final velocity, and time. What is not mentioned here is wonderful. What is not mentioned here is acceleration. So acceleration is not mentioned here. What about this equation? Yalla, have a look. So if you had a look here, you will find that Vf is equal to Vi plus A delta t. What is missing here is, wonderful, it is delta x. Here there is something missing, which is Vf. And finally, you will find that delta t is not mentioned here by any means. So each equation has something missing. And this is the key of solving these problems. Let's have an example. Let's say that a car accelerates uniformly from rest to 20 meters per second. Find the displacement after 2 seconds. So first of all, you need to have a careful look on the problem, and if you focus a little bit, you will find out that the key word is mentioned. So it accelerates uniformly. This means that I have to use one of the 4 kinematic equations. And it moves from rest, so Vi is equal to 0, to 20 meters per second. So don't you need to have a look on the unit, which is meter per second. So this is a velocity, not an acceleration, because if it's an acceleration, it will be meters per second squared. So Vf is equal to 20 meters per second. Find the displacement. I need the displacement, which is delta x. So delta x is missing, which is measured in meters. And finally, he gave you the time after 2 seconds. So delta t is equal to 2 seconds. So look at the givens and the question and search for what is not mentioned in the problem by any means. It is not in the given, it is not in the question. If you look carefully, you will find out that something is not here by any means, which is, I will give you some time to answer. Wonderful, the acceleration. So the acceleration is not mentioned here by any means, which means which equation can fit or can solve this problem. If you looked here, you will find that the first equation has no acceleration, which means that this is the only equation that can solve this problem. So substitute. So delta x is equal to half Vi plus Vf times delta t. So delta x, you need it because this is the displacement, half 0 plus Vf is 20 times delta t, which is 2, which is equal to half times 20 is 10, 10 times 2 is 20, so it is 20 meters. And this is your displacement. So this is the answer of your question. You suggested that it would be solved by the 4 kinematic equations because the word uniformly is mentioned here. and you got your givens and the question, and you found you search for what is not mentioned in both, and you found that acceleration is not mentioned either in the givens or the question. So you have chosen the equation that has no acceleration, and this is the only equation that will solve the problem. Let's have another one in the free fall. And the free fall questions are easy because they are somehow short problems, and it has lots of givens even if you didn't notice that. So let's have a problem on the free fall motion. Let's say that an object, or let's say that a ball here is dropped from rest. Find the height of the building after 3 seconds. So a ball is dropped from rest. Find the height of the building after 3 seconds. As you can see, there is only one unit, one given. But if you look carefully, you will find out that there are many givens, and the first given would be dropped. This means it's a free fall motion, so you need to use the 4 kinematic equations. Dropped is equivalent to the word uniformly. So if you found dropped, thrown upward, uniformly accelerated, constantly accelerated, all of these keywords mean that you need to use one of the 4 kinematic equations. So a ball is dropped from, dropped means that VI is 0. From rest, find the height. I need delta y, which is equivalent to delta x on the horizontal axis. So this is not known. The height of the building after 3 seconds. Delta t is 3 seconds. But we are missing something here because it's a free fall, so the acceleration is always given even if it's not mentioned. So it's 9.8 meters per second squared. So these are your givens and your question. What is not mentioned here by any means? I will give you some time to think. Wonderful. What is not mentioned here by any means is VF. VF is not mentioned here, so I need to go to the equation that has no VF, which is the third equation. Delta x is equal to VI delta t plus half a delta t squared. It has no VF, and this is the only equation that will solve this problem. So delta x is equal to VI times delta t plus half a delta t squared. By substituting, delta x here is delta y, so I need to change this into delta y because it's a free fall. VI delta t, which is 0 times 3, 0 times 3 would be 0, plus half 9.8. Delta t square is 3 square, which is 9. And you can finish your problem. Let's say that this 9.8 is approximately 10, so half times 10 is 5, 5 times 9 is 45. So it is 45 meters. This is the height. If you mention that the negative 9.8, that 9.8 is negative, your height would be negative, and this is logic because you are dropping an object. This means that the height is decreasing. So if you mentioned that 9.8 is negative, your height will be negative. So this is logic because the height is decreasing and the object basically is being dropped or falling down. So now we had examples on the free fall motion and the constantly accelerated object. I think that those equations are, those problems would be sufficient to examine the 4 kinematic equations. Now let's discuss something related to the graphs. As we mentioned here in our objectives, you are going to discuss velocity, acceleration, free fall. In order to solve problems of graphs, you need to first to look at the x and y axis of the graphs, because this is the key that will help you to solve such questions. So let's say that I have x axis here, y axis and x axis here and here, and I have here x axis and y axis. Here in the first graph, the x axis would be delta t, here also would be delta t in seconds. And here I would be having displacement delta x in meters, and I have, or x, which is position basically, it should be position. And here we have, so this is position in meters, and here we have velocity, which is meters per second. If you look carefully, if I have position and time, so what I am describing here is the velocity. So basically the slope here is the velocity, which is the rise over the run. The rise over the run is delta x over delta t would give you the velocity. So I am going to describe the behavior of the velocity in this graph. While here you have velocity and time. So the change in velocity over time describes the acceleration. This is the slope. So in this graph, you're going to describe the acceleration. So let's say that you have a graph that looks like that. And here also you have the same graph. So let's say that 0, 5, 10, 15, and 20. Here the same thing, 0, 5, 10, 20, 10, 15, and 20. Here these are positions, which means that they are in meters, and here they are velocities in meters per second. So from 0 to 10, let's call it area A or line A. This is line B and this is line C. The same in here, line A, line B, and line C. In line A, as you can see, from 0 to 10 meters, or let's make time as well, so 5 seconds. Let's make it 2, 4, 6, 8, 10, 12. So from 0 seconds to 4 seconds, which is this line A, the car speed was exactly A. It was positive constant. Positive constant velocity. Because any straight line going up, it's a positive because it's going up, and constant because it's a straight line. The same case for C. From 10 seconds to 12 seconds or more, the car basically was in area, the line C is negative constant velocity. The meaning of constant velocity, it means that the velocity didn't change at that time. If you calculated the rise over run, it would be the same value for you. Here would be the same also value for you. Rise over run would be the same value, but in a negative form. So what do I mean by a positive constant or negative constant? Does positive means that it is increasing velocity? No. Does negative means that it is decreasing velocity? No, because increasing and decreasing is totally, again, is being constant. Constant means it is the same value, it is not changing. So positive means that the car is moving forward, while the negative velocity means that the car is moving backward. So it is a matter of direction. What about the B part? The B part, the time is passing from 4 to 10. What happens here to the car from 4 seconds to 10? What does it mean that the time is passing but it is on 10 meters? What does this mean? Wonderful. This means that displacement didn't change. I mean, the position of the car didn't change, but the time is passing, which means that the line B represents zero velocity, or the car was at rest. This is the meaning of a horizontal line on a position time graph. The position is the same, the time is moving, which means that the car stopped basically from 4 seconds to 10 seconds. Let's discuss the graph here on velocity time graph. A and C are also constant values. So A is a positive constant velocity or acceleration. Wonderful. Acceleration. C is negative constant acceleration, because this is a going down line. While B means that the car has 10 meters per second for about from 4 seconds to 10 seconds. What does this mean? Does this mean that the car was at rest? It didn't move? No, exactly, because there is a value of velocity here. It is 10 meters per second. So the car actually was moving, but the movement of the car was constant. The velocity of the car was 10. So this means that acceleration was, if the velocity is constant, it doesn't change. What does this mean for acceleration? This means that acceleration would be 0. So the car wasn't accelerating in here. The car was moving with constant velocity, which is the cruise of the car. When you press cruise, this means that you are making this line. The car is moving on one speed. So this is the meaning of A and C, positive and negative constant, while B is zero acceleration. If we ask this question in order to be sure that we understood the graphs, where do you think we use the uniformal or the four kinematic equations? In A, B, or C? Where shall we use the four kinematic equations? Those ones. In which part of the graph in the velocity time graph? Wonderful. If you looked here, you will find that we use those equations in uniformal constant acceleration. And this area and this area are uniformal acceleration, constant acceleration. So we use the four kinematic equations here in A and C. So we revised the meaning of displacement. We revised the meaning of average velocity using the two rules. We revised the meaning of acceleration. And then we discussed the uniformal or constant or free fall problems by using the four kinematic equations, and we discussed the graphs: position time graph and velocity time graph.